G'day guys. I've had lots and lots and lots of questions about the variable damping. I'm going to give you a bit of a demonstration. I'm not going to make this big words and complicated. I'm going to just do it as simply as I can. And actually, that is a decay curve. You can see the curve from vertical going downwards, and that's just the receive window. And that thing after it is basically the power supply. A little bit of leakage from the power supply. That's where it starts up at the end of the receive window there. I can zoom out in a minute and I can show you all the intricate things. But while I've got this, I'll move that way a little bit. And yeah, basically all those spikes you see all over the place on the thick glowing line at the bottom there going horizontal, that's noise. That's noise spikes. So I probably got the gain turned up way too high. So I'll turn the gain down. As you can see, I'll get something to point, just so you know. What can I find? Here we go. An old paintbrush will do the job. Okay. This is at the end of the transmit here, and this is the poor old coil's been full of energy and it's letting go of the energy. Okay, and it comes down. As you can see, it's set at 10 microseconds. So within about 5 microseconds, odd, near enough, a little bit more, the decay curve comes down in a very short amount of time. I'll just zoom that out a bit. Like so. There you can see the curve. And you can see the top of it there. That's basically after it's been damped off. Now what you want on this curve here, you want this to be very sensitive and matched to the coil. I can show you what happens if we underdamp the coil. I'll just get on the detector here. Okay. And that's underdamping the coil. Now, if we're underdamping the coil, can you see here all these little lines going up and down? That's the coil ringing. It's an inductor, it's not damped, it just wants to keep oscillating. And that would be where your detector is receiving along here, and all that will absolutely destroy the sensitivity, or probably most of the target information. You do not want that. Now, if I start turning the damping up, you watch it. We get rid of all that stuff for a start, all those up and downs. We don't want those, and they're gone. Now, you can actually detect with the detector operating like that, but it's not going to be very sensitive. Let's keep turning the damping control and watch what it does. We've got a big sharp peak there. See that big sharp peak? It goes all the way up. I'll probably drop it down a bit more. So this is critical damping in a coil. Okay, that's underdamped. Now that I've got it, the resolution down, it's 50 millivolts a division, which means it's a lot of energy there, but we've basically dumbed it right off. So I'm turning it now, and you can see, maybe you can see, all around this area here is looking a lot smoother. Not as much jitter and things. So we'll keep going. Now watch this. We don't want to worry about the one next to it. That's all to do with the flyback and that. But if you actually watch what happens, see that's down, up we go, and there's a peak. Where that peak is, this one here. That means a coil is operating at maximum sensitivity and absolute optimum. This is as sensitive as almighty. Now, if we keep going, okay, we're back into that horrible underdamped, critically damped, about there. So that's as sensitive as this is how you want your detector, right? Now, if I go full factory standard damping, watch what happens. And the decay curve comes right down. The detector will work with it like that, but it'll lose maximum sensitivity to the coil. Now, the coil I've got on at the moment, sitting here, is a 14 by 9 Elite Max. Eugene, it's your coil. I know it's massive and big, and it's a mono, and I should not be using a mono in the workshop, but it was, yeah, it's pretty suitable for doing this. So every coil will have a different set of its own, I'm trying to think of simple words. Just the way it's built, it'll alter its electrical characteristics. So what I'm going to do, I'm going to get this Elite Max and I'm going to peak it. Okay, we're going to have a look at the peak, and we're going to get a standard, I don't know, how about we just throw on a MindLab mono coil, and I'll show you how out this coil to coil for peak performance is out. Okay, so let's have a look here, and we'll peak it. About there. So it's peaked as so. I should have actually used the markers for the peak, but that's good enough. It's basically nearly touching the second line from the middle. So yeah, got a few. I think it's the poor old battery's a little bit low at the moment. It might be affecting the way it's working. I don't know 100%. It's just that it had a couple of glitches there, and I've got the audio down because it was making flat battery noises. It's giving me the audible warning that the battery was going to go flat. So let's just have a look at it there. I'll turn the detector off. I won't try and bump anything too much. So this is the coil I was using, that one. So we'll take him away. Okay. Next coil, I'll just use this. It's a Commander mono coil. Okay. I've got to make sure the lead doesn't pull everything onto the ground. So let's turn the detector on. And I might have to just readjust the level here. Oops. Well, that's what we were looking at there. That it is very, very down in level. Now I'll get onto the control. That's it there. That's basically shows very little amplitude, doesn't it? That's just changing the coil. That's a Commander mono 8-inch. That's if I turn that on full damping, that's fully damped, and there's not much of a curve there. Wow. That's it. That's peaked. Just by looking at that, I'd be selecting the Coiltech Elite Max coil any day. Hang on, go try another coil. I don't know if that's I haven't run around trying lots of different coils, but I'll get one. I'll get a bigger one, a bigger Mindlab one. Try a double D. I'll just try a double D. It's not going to look at the receive winding. It's only going to dampen the coil's transmit winding. We'll just see how it goes. Just being careful here because I'm working behind the camera. I can't see what I'm doing very well. So anyway, let's see what happens. Okay. I'm looking at that and I'm saying, where's the decay curve? No, it's 50 millivolts a division, if you can read it on the oscilloscope. But I can move this. I'll move it to one of these little pulses here, because I probably in enhance, and have a look at that. That is basically very, very strange. Those Coiltech coils have got far less losses, by look of it, than the other coils. I want to have a look at my coil collection, just see what I've got. That's really amazing. Hang on a sec. Third I have got here, and we'll just see. I don't know if I can connect that up. Oh, yes, I can. I've got one of these things, okay? We'll give that a go. I was going to turn this off. Basically, actually, what I should do, I should put that down, and that's at 10 millivolts a division. And what we want, I just want to get that decay curve up. That's it there. Okay. And that's totally underdamped. And we've also moved the time window a little bit. So well, that's peak performance there. If I get a bit of metal, which shouldn't be too hard to find, and I go and put it near the coil, that decay curve will move. There's a massive difference in the way that these coils are behaving compared to the Coiltech one. The Coiltech one is far more sensitive. So that's what your decay curve would look like. I'll see if I can just, I'm going to try and balance a piece of metal near it. It's going to upset it no end if I do that. depending on the material that you're using, it's going to change the shape of the decay curve as well. So basically, as you come down, go across a target, it does that. And the detector just picks that up. That's all it's doing. So if I had the audio on, it'd be going woo, 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 like so. So what I'm going to try and do, I'm going to put something, I wonder if I can put a small target near it, just to get a bit of amplitude. Nope. What about a hot rock? No, not interactive enough. I've got to use something metal, but it can't be too large, and I can't have it directly on the coil. And I'll put that there. There we go. That's a piece. That's a pair of tweezers. So if I get on the decay curve, well, should I say damping? That's under. And that's optimum right there. I shouldn't have a piece of metal near it because it's going to cause ructions. But I'll put that. Well, actually, I'll go get the. Oh, can I get that? I've got to have more coils around here. You know, these older coils aren't probably the best to. That's all set up on a detector. I can't get that one. Hang on a sec. I want to find a big mono. What's that? That's a 6000. I'll have to go into my drawer of coils down here. Oh, hang on, what's that one? Oh, here we go. I've got a big Commander mono. We'll see how this goes. So I'll just get rid of the double D. Double D is not really. I know why we weren't getting any movement, because I've got the crow probe taking off on the double D part of the coil. If I run a mono, both are the same. If I have a double D, it's looking at the receive winding. It's not going to give any indication. Should have noticed that, but I just noticed it then. So I've got to have monos on, or else I have to go and move the oscilloscope probe where it's tapped onto the circuit board. Okay, here we go. This is the mono. Oh, look at that. There we go. Now we've got a proper decay curve. Yeah, because on the receive windings, on a double D, you don't have that. It's not there. So anyway, let's make sure that I took those tweezers away. Let me just adjust it a little bit. We've got a bit of a phase issue. There we go. So have a look at it like so. You can see that curve there coming up. So let's have an adjust. We'll see how it goes with a mono Commander. Okay, we'll take it all the way down, and we're going to get that horrible ripple there because we're underdamped. That is classic underdamped there. And if we then adjust it and we say, you could actually use the coil there, it would be stable. It would a little bit underdamped like that. No, it might be a little bit too sensitive, but let's peak it. We'll see how far we can peak it. That's just a time window jump. Don't worry about that. Okay, now look at that. That's factory damping. Okay, and we don't have really much peak at all, do we? So we back off the damping control, and right there, that's a sweet spot. So the coil is really, really sensitive there. If I get a piece of metal, just come near the coil. Yeah, I'm probably about, I don't know, probably about 24 inches above the coil, holding a little copper plate. So you can see it bouncing like so. That's your decay curve. So the thing's transmitting in here. That's a power supply leakage. It snaps off, generates, if I zoom out, you can see a big voltage spike going right up, which is a flyback from the coil. And as we know on these, it's clamped at about 185, 195 volts. So okay, won't sit in the middle. Oh, if I do that, then I use this. There we go. Oh, too fast. There you go. Put that in the middle of the screen. So I should be using the hold off control, but I'm not. That's your decay curve there, and that little dot up there, right where my finger is, little tiny thing, that's the flyback voltage. So that's sitting up there. If you actually measured it on the detector, it'd be about 185, 190 volts, and you can see that that's massively underdamped. You can see it even ringing here. It's got another peak. We don't want that. We want it to be like that. That's optimum. So that is how this control works. That when you get this and you turn it flat stick, there you go. You lost all your sensitivity because it's overdamped. And all these detectors, these GPs and GPXs and SDs all came out with one damping value. One damping value fitted all. And I suppose they all came out with exactly the same coil, all made exactly the same way. That would suffice. But because we have so many different types and coils and different manufacturers, the build of the coil, they are all different. And to make them work properly and effectively, you have to control the damping in the detector for the coil. And it's a complex thing. It's to do with the inductance, it's to do with winding spacing, it's to do with the resistance of the coil, how low ohms the winding is, the cable capacitance, the cable inductance, cable loss. All these things all come into play, even the plug on the end to a degree. And yeah, one resistor value for all just does not work. So as you probably saw out in the field, when I was first doing it, mucking around, when I was getting into that sweet spot area for matching the coil to the detector, the sensitivity went through the roof, and it was really, really stable. So, you know, over damping or under damping is not what you want to do. So you want to have that right there, and that's at 200 millivolts a division. But I'll zoom in, and you can. That's at 20 millivolts a division. So you can see that it does make a big difference. So there you are, totally underdamped. See all that ripple? That'll be screwing up the signal coming into the detector or how it processes it. It'd all be riding on that noise, and it would sound like that. Also, you get distortion as well. So there's a lot of things you probably can't see, but then you go, bang, up she goes. It wants to operate there. It's happy as Larry. So everything is tuned spot on to how the coil wants to work, not over damped, not under damped, critically damped, and that's how it works. So, you know, even with we can probably even get a small target. I don't know at that level. Oh yeah, there you go. I'm just putting a 0.1 near the coil, and you can see the top of the decay curve moving. That detector would be picking that up. So it's 0.1 on a 11-inch mono. and we're at 20 millivolts. This thing's looking well below those levels. That would be a screaming signal. And I'll just turn the amplifier on. You got to remember, we're running a mono. And there goes that. Told you battery was going flat. So that's a 0.1. You can hardly see it move, but it's detecting it. And if I use something bigger, and I'll show you something interesting. These are called motion detectors, because if I hold a piece of metal, well, I'm going to hold that in my hand, a particular distance above the coil. Have a look at the decay curve and tell me what you notice. Right. And I'll get it up there. Now I'm not moving my hand anymore. Notice that the detector is settled down. Even though the metal's there, it's not saying anything about it because the decay curve is not moving. It needs to move. I'm just moving my hand sideways a little bit. That's basically how you tune ground out. So you can detect on that. If I went near it with another piece of metal, it will detect it. Well, basically, look at this. I'll get the curve up like so. I'll put those there. Ooh, okay, and I'll get another piece of metal. How about, see the curve's up, right? Let's get another piece of metal. Say a capacitor. So any movement of that decay curve makes a signal. So yeah, that's it's on low gain at the moment, by the way. I could turn the gain up, but you don't want that. Now if I turn the gain up, you watch the decay curve. There you go. Righto, and there's buckets of noise. That's the noise we're going to put up with in this environment. So all those jiggles and wiggles there, the detector's going completely bonkers. I'll just turn the gain all the way down. So yeah, so if the gain right down, you can run a mono in your room, but you shouldn't do it because there's a lot of noise here. Anyway, that's a 0.1. I don't know if I could pick up the 0.05. Yeah, I can. Can't see it move though. Oh yeah, can. Probably the noise. I don't know. Clutching at straws. So I don't even know what mode I've got this thing. Oh, I had it in normal timings, by the way. So I'll just flick it into. Now I flicked it into fine gold, and just give that 0.05 a whack on it now. That's too much noise. When you go to fine gold, you notice the noise comes up because the receiver timings are coming in closer. If someone turns a light on, and that's what happens. So we'll see how the damping goes between modes. See if we can peak it anymore. See, that's full damping. Sorry. No, that's underdamped. I can see the ripple. Yeah, got a bit of ripple there. So that's a damping peaked about there. Let's see if I can hear that. Now I can hear that. Now I can hear that 0.05. See, damping makes a big, big difference. Now I'll put it back to how this thing would come out from the factory. which is there. That's full damping, and we'll see if we can hear the 0.05 now. It's in the noise, but I'll peak the damping again. Right there, it's good enough as peaked. Even in all the noise, we can hear the target. So, and if we go totally under damped, which you can see that rip, can't hear anything. I'll even use a bit of copper I was using, right? It does work, but notice how the detector is completely, it's just deaf. It's basically destroying the very, you know, the samples that you would take in here. Oh. Well, basically, it's just generating lots of crud, and the whole system falls over. It can't handle it. And as a matter of interest, what I'm going to do, I want to see how high I get this copper plate with the whole thing totally underdamped. Okay, there. I'm just lining it up with some of the stacked containers I've got here. Now let's peak it and we'll see what happens. So, you know the detector's working, you hear the noise. Oh, about another 12 inches higher. So, battery's going to go flat because I'm using the Super Gold Finder battery. But yeah, that's how the damping works. That's me touching the camera, probably generating some sort of artifacts. But yeah, that's that, and yeah, just using the 11 mono. So yeah, you can peak all your coils quite easily. So yeah, people are asking about it. I do want to get out and do a proper field video. Could I do it? Yes, I can do it. As a matter of interest, do you want to see a standard detector where the damping sits? I've probably got a standard one sitting in that's come in, and I haven't done it yet. So, but I might have to. Think it's probably a lot more to muck around with doing that, like quick turn ons and turn offs, two detectors side by side, and yeah, doing it on the oscilloscope. I can show you, but I know for a fact that the damping on a standard detector, it's going to look like that, because that's what it works out in resistance value. So there you go, guys. Yeah. Oh, I wanted to bounce there. Oh no, I think it could be the battery going flat. There's something going on, but anyway, that's basically, yeah. The death chime. Yep, I think we're going to lose our battery. Anyway, that's good enough, isn't it? I hope that explains some things. Look at it jumping up and down. Why are you doing that? Yeah, maybe, I don't know. I only just pushed the coil connector and I didn't tighten it, so maybe that's it. Oh yeah, it's moving things around. Okay, that's enough of that. So that's how it works, guys. That is the damping control on the detector, and If I get that, it's hard working behind this camera. As you can see down there, this has the extra control on it. So makes it quite neat, doesn't it? In different colours so you don't get muddled up. Oh, there it goes. So catch us later.